Hi guys, this is Chian, and today we're gonna do the surveying fieldwork number 4, which talks about the differential leveling. So what is differential leveling? Differential leveling is the process of measuring vertical distances from a known elevation point to determine the elevations of unknown points. The most common method to determine the elevation are through the use of a compensator type, which uses automatic engineering level, and with the use of level rods. Number 2 is an electronic digital barcode leveling instrument with a barcode rod on it. So the barcode is attached to the rod. Here are the materials needed for differential leveling, which is leveling rod, precise level, marking pins, which is chalk or either marker, and lastly, plumb bobs. There are various types of leveling. These are the differential leveling, the trigonometric leveling, indirect leveling, three-dimensional coordinates, and GPS survey leveling. So in this survey, we will only tackle about the most basic leveling, which is the differential leveling. And that's it. Let's now proceed to the procedure.
For Part A, single setup differential leveling, the first step is the instructor assigns the location of 2 points marked as A and B, which are intervisible with the instrument setup placed between the points. Then, set up the instrument level on the suitable points, preferable about midpoint of the 2 designated station A and B, by driving the tripod firmly on the ground. Adjust the height of the instrument to the convenient level of instrument man through tripod legs locks. Next, check the bubble in the vial of the level if it is in the center. If not, adjust the screws by rotating clockwise or counterclockwise. Then, take the backside reading of point A, where the leveling rod is being held vertical with the aid of a plumb bob. The reading must be done up to the accuracy of a millimeter or 1,000 of a meter. Then, rotate the telescope after point B is in sight.
Number 6. The rodman transfers a leveling rod at station B and must hold it with plumb bob alongside to maintain verticality of the rod.
Take the foresight reading of leveling rod, and again, the reading must be done up to the accuracy of millimeter or 1,000 of meter.
Number 8. After recording the observed values, compute for the difference of the readings to determine the difference in elevation between benchmarks.
Repeat procedures 1 to 8 for second and third trial.
Number 10. Tabulate the data in Table 4.1 Single Setup Differential Leveling.
The instructor assigned the location of another 2 points marked as A and B. Set up the instrument level on the suitable points, preferable about midpoint of the 2 designated station A and B, by driving the tripod firmly on the ground. Adjust the height of the instrument to the convenient level of instrument man through tripod leg locks. Check the bubble in the vial of the level if it is in the center. If not, adjust the screws by rotating clockwise or counterclockwise. Take the backside reading of point A, where the leveling rod is being held vertical with the aid of plumb bob. The reading must be done up to the accuracy of millimeter or 1,000 of meter. Rotate the telescope until the newly established point designated as turning point can be sighted. Ensure that the turning point should be almost equidistant from the instrument as the first benchmark from the instrument.
Number 6. The rodman transfers the leveling rod at TP and must hold it with plumb bob alongside to maintain the verticality of the rod. Take the foresight reading of TP, where the leveling rod is being held vertical with the aid of a plumb bob. The reading must be done up to the accuracy of a millimeter or 1,000 of meters. Number 8. Transfer the instrument to another location along the route BM2 where the first turning point is still visible in the telescope, and follow the same procedures as in 228 until you reach the second benchmark. Number 9. Tabulate the data in Table 4.2 Differential Leveling with Turning Points.
In Table 4.1, or single setup differential leveling, there are 3 trials that were done. In the first trial, the obtained backsight is 2.06 while foresight is 2.61. In trial 2, the backsight is 2.07 and the foresight is 2.60. And then in the last trial, the backsight and foresight is 2.04 and 2.62 respectively. To obtain the difference in elevation of each trial, the backsight was subtracted to foresight and the result is the absolute value of the difference. For trial 1, backsight of 2.06 subtracted to foresight of 2.61, the absolute value of TE is 0.55. For trial 2, backsight of 2.07 subtracted to foresight of 2.61 is equals to absolute value of 0.53. And then in the last trial, backsight of 2.04 subtracted to foresight of 2.62, the result DE is 0.58. Finally, to get the most probable difference in elevation, just calculate the average of the obtained 3 differences in elevation. Substituting all the values, 0.55 plus 0.53 plus 0.58, then divide it by 3, the most probable DE is 0.53.
The first thing we need to do is add the backsight of BM1 to our elevation, which is the 100 meters. So 100 meters plus 1.256, then we will get the height of instrument in benchmark 1, which is 101.256. Then to get the elevation in TP1, we need to subtract the foresight in TP1 to our height of instrument in benchmark 1. Then to get that, we will use 101.256 minus 1.886, then 99.37 is the answer. Then repeat the procedure in the first solution that we did. 99.37 plus the backsight in TP1, which is 1.116. Then we will get the height of instrument in TP1, which is 100.486. Then to obtain the elevation in TP2, we need to subtract the foresight to the height of instrument in TP1. Then the answer is 98.959. Then we need to add the backsight of TP2 in this LF to get the height of instrument of TP2. 98.959 plus 1.228, 100.187. That's the height of instrument in TP2. Then to get the elevation of benchmark 2, we need to subtract the foresight of height of instrument in TP2. 100.187 minus 2.243, then we will get the 97.944. So for us to get the same answer, to verify our answer, we need to do the arithmetic check. The summation of backsight, we need to get it. 1.56 plus 1.116 plus 1.228 is equal to 3.600. Then we need also to get the summation of foresight. We need to take note that the sign is negative since it is foresight. So 1.886 plus 1.527 plus 2.243 is equal to negative 5.566. Then we need to add all of it. The elevation of our benchmark 1, which is 100, then the summation of BS, our backside, and foresight. Then the answer is the same, 97.944.